We are in the Master Degree class of Library and Information Science. We shall cover Unit 4, an Introduction to Data Management under the course on Information Communication and Society. Effective data management has become a crucial component in this data-driven society. It encompasses the practices, policies, processes, and technologies that organizations implement to collect, store, organize, secure, and leverage data efficiently. This class provides a comprehensive overview of what data management is, what are its different types of stages, and how it may effectively be conducted in different stages. As data becomes an increasingly valuable asset for decision making and strategic planning, effective data management has become a critical aspect of running a successful modern organization. Data management refers to the practices, policies, processes, and technologies that organizations use to collect, store, organize, secure, and utilize data effectively. Effective data management is a multifaceted discipline including data integration and storage to data governance and security. Data management ensures that data is accessible, accurate, and secure, enabling organizations to make informed decisions and achieve their objectives. As the volume and complexity of data continue to grow, management of data will remain essential for businesses, governments, and other entities striving to thrive in a data-driven world. Now, what is data management? Data management encompasses a broad range of practices and tasks aimed at ensuring the accuracy, accessibility, security, and usability of data throughout its life cycle. It involves the collection, storage, organization, retrieval, and sharing of data across various systems and platforms. Now, how data management practices evolved? Data management practices have evolved significantly over the decades, driven by technological advancements, increasing volumes of data, and the changing needs of businesses. Data management has evolved from simple data storage system to complex integrated solutions that ensure data is accurately stored, securely protected, and effectively utilized. In the early stages during the 1960s and 1970s, data management was primarily focused on storing and organizing small datasets in mainframe computers and early databases. During this time, data was often siloed and there was limited ability to analyze or integrate it across systems. Data was mostly structured and manual methods were used for storing and retrieving information. The relational database era during 1980s and 90s. The introduction of relational databases marked a significant shift in database management. Databases like Oracle and SQL Server enabled organizations to store data in tables and establish relationships between different data points. This allowed for more efficient querying, storage, and retrieval of information. During this time, database management system or DBMS system became central to data storage. Next come the data warehousing and business intelligence period during 1990s and 2000s. The need for analyzing large data sets from different sources led to the rise of data warehousing. Data warehouses allowed organizations to aggregate data from multiple operational systems into simple centralized repository. The concept of business intelligence tools emerged, enabling companies to analyze historical data and generate reports and dashboards to make strategic decisions. Next comes the big data era during 2010s decade and till today. The explosion of digital data driven by the rise of social media, Internet of Things devices and cloud computing has created the need for new approaches to data management. Traditional databases and storage systems were not equipped to handle the sheer volume, variety and the velocity of big data. In response, organizations adopted technologies like Hadoop, NoSQL databases and cloud storage platforms to manage and process large-scale datasets efficiently. Next comes the data governance and privacy concerns during 2020s. In recent years, as data security and privacy concerns have grown, organizations have focused more on data governance, ensuring compliance with data protection laws like GDPR, securing sensitive data and establishing clear data ownership and accountability have become top priorities. Modern data management practices increasingly emphasize the need for robust governance frameworks, automated monitoring and audit traits. The future of data management. Now, where we are going in the coming years. As organizations continue to generate and rely on more data, future data management practices will likely incorporate advanced technologies like artificial intelligence, machine learning, blockchains, which are already in use. These technologies can help automate data processing, improve data quality, enhance security and enable more advanced forms of analysis. What is big data management? Big data refers to extremely large and diverse collections of structured, unstructured and semi-structured data that continue to grow exponentially over time. Big data is characterized by volume, variety, velocity and veracity. The sheer amount or volume of data generated daily is immense and requires specialized tools and storage solutions. And what is variety of big data? Data comes in many forms: structured, semi-structured, unstructured, requiring diverse management approaches. And the velocity of big data, the speed at which big data is being generated, processed and analyzed. And the veracity, ensuring the accuracy and reliability of massive data set is crucial, as big data often includes inconsistent, noisy or incomplete information. And big data management involves the process and technologies used to handle, store, process and analyze extremely large data sets that traditional data management tools and systems cannot efficiently manage. Now, what are the core components of such big data management. The core component of data management include data collection, data storage, data security, data governance, data integration, data quality management, data analytics, data backup and recovery, master data management. Now, what is data collection? Data collection is a gathering of data from various sources such as databases, sensors, applications or user inputs. And next, data storage. Storing data securely in databases, data warehouses or cloud storage solutions is data storage. The component data organization involves structuring and categorizing data to make it easily retrievable and understandable. Data security is very vital component in this data management process, implementing measures to protect data from unauthorized access, breaches or corruption. Next comes data governance, which establishes policies, roles and responsibilities to ensure data integrity, compliance and accountability. And data integration combines data from different sources into a unified view. And data quality management ensures data in accurate, consistent and free of errors form. And data analytics analyzes data to extract meaningful insights or information for strategic decision making. And next, data backup and recovery creates copies of data and ensures it can be restored in case of loss or disaster. And finally, master data management maintains a single authoritative source of key business data. Now, these are the components of data management. These are the core components, and within each component there are various other aspects. Importance of data management in modern organization. Why should we concern about data management in today's data driven world? Data is often referred to as the new oil because of its immense value in driving business growth, innovation and competitive challenges. In today's digital world, organizations generate vast amount of data through their operations, customer interactions and various business processes. However, raw data alone is not useful without effective management. Proper data management enables organizations to make informed decisions, improve efficiency, ensure regulatory compliance, enhance customer experience, promote innovation and ensures data security and risk management. So, proper data management enable organization to make informed decisions. Accurate, well organized data enables managers and executives to make data driven decisions, improving business outcomes. Efficient data management reduces time spent searching for and handling data, streamlining workflows and increasing productivity. Data management also enables organization to promote innovation. Well managed data enables organizations to analyze trends, identify new opportunities and develop innovative products and services. It also ensures data security and risk management. Data management ensures that sensitive information is protected, minimizing the risk of data breaches or unauthorized access. Also helps to maintain scalability. Efficient management of data facilitate growth by ensuring systems to handle increasing volume of data. Now, types of data management. As organizations increasingly rely on data to drive their strategies. Understanding and implementing the key types of data management has become essential. Each type of addresses specific aspects of data handling, ensuring that data is accurate, secure, accessible and usable. Data management encompasses various practices and strategies to handle data efficiently throughout its life cycle. Key types of data management are data integration, data modeling, data storage, data catalog, data processing, data governance, data lifecycle management, data pipelines and ETLs, that is extract, transform and load, and data security, data architecture. So, we discuss this one by one now. So, what is data integration? Data integration is the process of combining data from multiple sources into a unified view. In an era where organizations use diverse systems and platforms, data integration ensures that information flows seamlessly across these disparate systems and datasets work cohesively. Techniques like extract, transform and load, that is ETL, and data visualization enable consolidating and harmonizing data. By integrating data effectively, organizations can derive holistic insights, enhance collaboration and streamline operations. For example, integrating customer data can provide a 360-degree view of customer behavior, improving marketing strategies and customer services. Now, what is data modeling? Data modeling involves creating visual representations of data systems, highlighting the relationships between different data elements. It serves as a blueprint for designing databases and understanding data flow within an organization. Effective data modeling enhances communication between technical and non-technical teams and ensuring that systems are built to meet business needs. Data models are categorized into conceptual, logical and physical models, each serving distinct purposes. As example, data modeling may be used for designing a database for e-commerce platforms or mapping customer journey data in marketing systems. Data storage. Data storage is the backbone of data management, providing a secure and efficient way to save and retrieve data. Organizations can choose from various storage options including cloud storage, on-premises servers and hybrid solutions. The choice of storage depends on factors like scalability, performance and security requirements. A data catalog is an organized inventory of data assets within an organization, often enhanced with metadata to improve data discoverability and usability. Data processing. Data processing involves transforming raw data into meaningful insights. This process can be manual, mechanical or electronic, with most modern businesses relying on automated data processing for speed and accuracy. Methods like batch processing handle large data sets at scheduled intervals, whereas real-time processing enables instant data analysis. Accurate data processing is crucial as errors can lead to misguided strategies and decisions. Data governance. Data governance is the framework of policies, processes and standards that ensure data is managed effectively and responsibly. It ensures data quality, compliance and access control. Data lifecycle management or DLM focuses on managing data throughout its entire lifecycle from creation or deletion. This includes stages like collection, access, usage, storage, transfer and deletion. Data lifecycle management helps organizations optimize the value of their data while ensuring compliance and security. As for example, a healthcare organization can use data lifecycle management to manage patient records, ensuring that sensitive data is securely stored and deleted when no longer needed. Data pipelines refer to the pathway through which data flows from one system to another, often involving transformations along the way. ETL, extracting, transforming and loading, is a specific type of data pipeline that extracts data from multiple sources and transforms it into a usable format and load it into destination system. ETLs are essential for consolidating data from disparate sources, enabling comprehensive analysis. For example, migrating legacy data to modern systems. Data security. Data security involves protecting data from unauthorized access, breaches and corruption. With increasing cyber threats, robust data security measures are critical for safeguarding sensitive information. Techniques like encryption, access control and regular backups help organizations mitigate risks and ensure data confidentiality. Data architecture. Data architecture provides a structured framework for managing data within an organization. It is the blueprint for how data is collected, stored, processed and accessed, aligning with the organization's goal and strategies. We here present different fields or different types or stages of data management system in areas like healthcare, e-commerce, finance, government, telecommunication, etc. Because data management is essential everywhere nowadays. Healthcare organizations gather patient records, medical histories, lab results and IoT device data. In case of e-commerce, they collect data such as customer demographics, purchase history, website interactions and payment data, etc. In finance, data like transaction data, credit histories, customer profits, etc. data are collected. In case of government, citizen information, tax records, public service usage data, etc. are collected, and in case of telecommunications, they collect customer usage pattern, network performance data, etc. In case of data storage, healthcare stored data in electronic health records systems and cloud-based medical databases, and e-commerce sectors use cloud-based platforms and data warehouses for scalable storage. And in case of finance, they store data in highly secured financial databases and cloud platforms. In case of government, they store data in government databases and cloud storage and physical storage. And in case of telecommunications, they store data in network databases, cloud platforms, etc. In case of data processing, healthcare organizations process patient data for diagnostics, treatment plans and medical research. E-commerce sectors process data for customer segmentation, recommendation systems and inventory optimization. In case of financial sector, they analyze transaction patterns, risk assessment and fraud detection. And in case of government processes data for policy making, public service delivery and infrastructure planning. And in telecommunication, they process data for network optimization, customer service, revenue tracking, etc. How data uses are maintained or managed in case of healthcare or e-commerce, etc. In healthcare, they use their collected and processed data for patient care, healthcare analytics and disease prevention. In e-commerce, data are used for personalized marketing, pricing strategies and for enhancing user experience. In financial sector, data are used for investment strategies, customer financial services and compliance reporting. In government sector, they use data for governance, public welfare programs and national security. And in telecommunications, they use data to enhance network reliability, target marketing campaigns and improve customer retention. Next, data are managed for data governance. In healthcare, they comply with healthcare regulations and maintain strict data integrity and accuracy standards. In e-commerce, they implement data privacy policies and comply with regulations like general data protection regulations for handling customer data. In financial sector, they adhere to financial regulations ensuring accurate and ethical data usage. Government ensure compliance with data protection laws and maintain transparency in public data handling, and telecommunication sectors comply with telecom regulations for data handling and ensure transparency in customer data usage. Healthcare sectors protect patient data with encryption, secure networks, etc. E-commerce use advanced encryption protocols for protecting payment information, user credentials, etc. Financial sectors implement robust encryption, multi-factor authentication and regular audits for data protection. Government secures citizens' data with strict access control encryption. Telecommunications secure customer call records, network logs with encryption and firewalls. Healthcare delete patient records as per legal retention periods or anonymize for research purpose. Financial sector securely delete data following legal and regulatory retention requirements. Government sectors delete sensitive data as per retention policies, and telecommunication sectors delete customer data after contract. These are some data management procedures or issues in some selected fields. In other fields, likewise, data are managed in every stages. Now, here we mention some standards and technology used for data management. Now, what tools are well used for data management in some various sectors? Now, what are the challenges in data management? Data management involves the collection, storage, organization and utilization of data to support decision making and business operations. However, the rapid growth of data volume, variety and velocity has introduced several challenges. The exponential increase of data generated by digital platforms, IoT devices and social media makes it challenging to store and process large data set efficiently. And data comes in diverse formats including structured, semi-structured and unstructured format. This requires advanced tools and techniques for managing those data. And the velocity or speed at which data is generated and need to be processed, especially in real-time scenarios, poses a significant challenge. Ensuring data quality such as data accuracy, consistency and completeness is critical, and poor data quality can lead to incorrect and flawed decision making. Data governance. Establishing policies and processes to manage data ownership, access control and usage is essential but can be difficult to implement across large organizations. Cost management is also another challenge in data management because technological complexities is also a challenge. In this class we have discussed what data management is, what are the different issues in data management such as the types of data management, and we also presented a case study on some specific selected fields, and that is all for today's class. Thank you.